Why does the double-slit experiment behave so strangely? Imagine watching tiny particles like electrons or photons dance across a screen, and suddenly they change their behavior just because you look at them. That's what makes the double-slit experiment so fascinating and puzzling. When particles pass through two tiny slits without anyone watching, they create a pattern of bright and dark bands on the screen, kind of like overlapping waves in water. This pattern shows that particles act like waves, spreading out and interfering with each other. It's as if each particle is passing through both slits at once and interfering with itself, which is pretty wild. But here's where it gets strange. If you try to measure which slit a particle actually goes through, the interference pattern vanishes. Instead, you see two simple bands, like tiny balls going through one slit or the other. It's as if the act of observing changes everything. This is called the observer effect in physics, and it's a core part of quantum mechanics. It suggests that particles don't have a definite path until they are measured. Instead, they exist in a superposition of many possibilities, described by something called a wave function. When you measure or observe, that wave function collapses, forcing the particle into a specific state. This collapse is what causes the interference pattern to disappear. It's like the particle knows when it's being watched and changes its behavior accordingly. This weirdness challenges how we think about reality. It's not just that we observe the universe. Our observation actually influences what happens. This phenomenon is tied to the fundamental principle of wave-particle duality, where particles can behave like waves or particles depending on whether they are being watched. The more we try to pin down their exact path, the more their wave-like nature fades. It's as if the universe is playing a game of hide and seek with the truth. The double-slit experiment shows us that at the tiniest scales, reality doesn't follow the rules we're used to. Instead, it behaves in ways that seem almost magical, revealing a world where observation and measurement are part of the story itself. This experiment remains one of the most striking examples of quantum weirdness, reminding us that the universe is stranger than it appears, and that our role as observers is more important than we might think.